Hello and welcome back to Java with Ali. I am Ali and today we're going to talk about merge sort. So if you haven't seen the other videos, there is insertion sort, linear search up already, and binary search. And now we're going to look at merge sort. Finally, something efficient. So as we know from the previous video, when I spoke about the previous videos, that I spoke about them being inefficient, but you can use them for small things. And even when you look at how it's run on my own computer, you can see that it's quite slow even on this machine. So you can imagine when there's thousands or more that it would take a lot longer. And as we know for hardware, we're looking at memory and also the space capacity. So both are very important for performance, and with performance we spoke a little bit about the big O notation as well. So merge sort is an efficient sorting algorithm, but is conceptually more complex. So this is going to maybe need 2 videos. I will put the code up after all of the sorting videos up on GitHub, so you can have a look at it. And the merge sort algorithm sorts an array by splitting it into 2 equal sized sub arrays. So you have, let's say, an array of 10. It will automatically split it into 2 arrays of 5. Then they're sorted, each of those are sorted, and then they're merged into one large array again afterwards, and that's why it's called merge sort, because you split, sort, merge, split, sort, merge, SSM, that's how you do it. With an odd number of elements, the algorithm creates 2 subarrays, such as one that has one more element than the other, and that's okay because you're never going to have an even split. And the implementation of a merge sort is also an example of recursion. And if you're not sure about recursion, please check out my previous videos about recursion. Recursion is when a method basically calls itself. So the base case is an array with 1 element, and that's already sorted because there's only 1 element. So then it immediately returns in this case, but the recursion then step splits the array into 2 approximately equal pieces. So if we have again 10 elements in our array, then we'll have 5 each. So recursion then sorts them and then merges the 2 into the 1 large array. So combining these then, we're going to have a look at the methods that are created as a result. So it is a bit longer program. Be prepared, but don't be too frightened, because we basically repeat a lot of the stuff, and we do call things like while loops within if and vice versa as well, which will come to that in a second. So I'm going to pause the video now so you can see my screen, because I do believe you're just looking at me right now. So I'll see you in a minute. Bye. Hello and welcome back. Okay, so I have arranged this program and most of my programs the same as usual, where I put the way that the methods are called in sequence. Others do it differently, but I like just for readability as well. So we're starting with the main thread of the program. We create a set of random numbers. We have here, we know that we're going to use arrays, and we know that we're going to use secure random as well. We have an int type array, and it is going to generate, you can see here. So when we hover over ints, you can see the stream size, random number origin, and what it's bound. So the size is 5, so we're going to pick 5 numbers from 1 to 10, or 1 to 100. And it's going to obviously put it into an array and store it in an integer array called data. That is going to be printed out. These are the same similar main methods that we used previously. So if you're unsure, please check out my previous videos. Merge sort then is the method that's called, and we're going to pass this generated 5 numbers into merge sort. So now, because I've gone to merge sort, I'm going to skip down in sequence. So we've got merge sort here, we pass in our data. Oh, look at that, we now call sort array. And so sort array then takes in data, and we can see here that we've passed through 0 as low, and then data.length minus 1. Always with the length versus array index. So with that then, we have our if here. So we have our sort array, data, low, high. We have our if here, high minus low, greater than or equal to 1. And then we have 2 more integers here that we've created, middle 1 and middle 2. Now, we need to sort the array first. So we have our merge sort is here, and then we sort the array, merge sort being the method that we've called, pass through our data. Here's our sort array. We pass through our data and we've said 0, and then we've taken the data length minus 1. Okay, we've now called those low and high. High being the data.length minus 1. So with that then we also have here, if we go down by code by line even, we also have our 2 new integers which are doing the calculations to split it. So with everything that we've said so far, and with everything that we have written down and gone through and everything, we already know that merge sort is more efficient. Why is it more efficient? Because it's going to split your data. Let's say you've got 1,000 or 1,000,000 customers, and you just split it in half, and then you sort those 2 halves first, and then you're going to like figure out how to do it. So basically, along the way, this is testing your base case here. So if it has 1 element, so if it's not the base case, this is if it's not the base case. Hold on now until I remove some spacing. So we test the base case and the size of the array equals 1. If it's not the base case, then we have calculate the middle of the array, which we know already that we need to divide it by 2. And then we calculate the next element over, so 1 over. Then we call another method to output the split. So we go down to sub array, which will go down here. And we use our string builder. Ooh. So with our string builder, we know the difference between string buffer and string builder already. If you're not sure, please check out my videos on string builder and string buffer. And with that, we want to output the elements here. We want to output the elements here for alignment, output elements left in the array, and then return those then here. So let's say actually I need the same amount of spaces. So if I copy this and put, yeah, that's better. Save. Okay, and then we go back here, returns it to the string. Then it obviously prints it out then to the string on screen. It does the same with data, low and middle 1, data, middle 2 and high. And then we go to sort array. So this is our next method. So where's our sort array then is a recursive. See, it will do it again. Here is our sort array. This is our recursion because it calls itself until it's completed. And then at the end it calls merge again. Merge, which is a new method even, and it's down here. So let's talk through this. We have data, left, middle 1, middle 2 and right. We assign left to the left index, middle 2 to right index, left to combined index. And then with each of those, with merge especially, we're working with like a temporary array as well, because with the temporary array, like with the towers of Hanoi and these other types of algorithms that you've just shuffled around things. So a lot of the time we use a temporary variable so that you can use it. And then we have our combined, which is our workable array. Then we want to output it, so we call substring again. So it basically converts it to the string and appends the space as well. And then we finally find ourselves in our while, which is going to be merging until reaching at the end. So we have to place smaller of two current elements into result and then move to the next space and so on. And we do the same then with left index. If the left index is empty, copy in the rest into the right, and eventually then we come to 4, which is copy values back into the original array. Because we're using a temporary array, it allows us to do that because we need somewhere to put it so that we can put it back, because we can't just let it equal to equal. Now we have our output here, which is also calling our sub-array string, data left and right. And there you have it. That is our merge, sort, test. And then at the very end, it says sorted array. So the after picture. So when you trickle down, the same as with our stack. So we have our left in, first out stack and our method call. So with our method call, until it's finished and goes back, then we can call another one, and we have this open all the time until we call another one and it goes back up the way. So if we were looking at the call of these methods here, we have merge that's called here, but we also had sort array and sub-array string as well. So if I press play, then you can see, so this is the after picture because it goes all the way back to the main again to show it. So we have our split. So here's our original unsorted array. So we have 5 numbers. We have to split it. We can't split it evenly. So one side is going to have 3 and the other side is going to have 2. And you can see here there's 3 numbers and here's 2 numbers. Then we have to sort it as well. So we have our splits that are continually happening until there's 1 number. Then we have our merged again, and we go through splitting again. And eventually we come to 9, 53, 70, 15, 21, and then we have 9, 15, 21, 53, and 70. So if we talk through this in a little bit of detail. So we've already covered a little bit of the main method already, because that was similar to the previous example videos. Where we really start is with our merge sort, that we pass it through to another method called sort array. This is going to sort everything first, but it's recursive. So we go through here as our base case is whether these are going to be greater than or equal to 1. Greater than or equal to 1. So this is where if it's 1, then we don't need to sort it. So here we have our int middle, which is going to take the middle of the array. Then we have our 1 element over, and we print out our split. So if I say here, this might be easier to see the split 1, 2, 3, might be easier to look at. You can also, a good way to go through and step through code, you can do debug stepping through as well, or you can also put in system out printf throughout your code and print it out on the screen as well. You can do both. A lot of programmers prefer one way or another, or mixing both together to see the output, especially if it's someone else's code and it's hard to read. So you can see here that it's going through it. This is their first call of our sort array, and then this is the next one because it's still not done, and then this is the next one, and then the merge, which is going to be here 35. on line 35. When we merge, then we want to also create a temporary array. So we have to put in our temporary information in there before we can shuffle things around and then output the actual final one as well. So if I was to take, instead of 5 elements, let's take 4, because it's an even split. It might be easier to see the outcome. So 67, 60, 46, 75. So this is our first, 67, 60, 46, 75. Then it splits it, then it splits the first part, then it splits the second part, then it splits this as one element, and then again as one, and merges 67, 60 together. Then it looks at the second array part. So this all, you can see here, it only takes, if I can use my mouse no I can't. It only takes this part and then it merges it, and then it takes this part and then it merges it, and then it merges both of them together, and then it sorts the array. So let's look at, down here we have merge, which is a really important part of it, because once we merge we have to merge the two sorted arrays together to combine both of them together, and that's why they're called combined. So with merge, then we have left index left, sorry, I think there's something on my left index left, right index middle 2, and so our middle 2 comes from here. So when we call merge, let's look at our call first, so see what's passing through it. So we have data, which is our original array that we created in the main method that we passed through originally to merge sort, then we passed it through to sort array, and then we also passed it to merge. But you can see with sort array that the output is, let me see, sort array. That the output, it has to go through multiple times. So it has to keep going on a loop before it's finished. Recursion. So here we have our merge again. So we have our original array. I'm saying original array because it's called data. Low, not to be confused with the other side. Low, which is a 0. Originally it was 0, declared as. And then middle 1 is going to be our split, our middle point. And then middle 2 is one element over from the middle. So it might make it easier then to understand which part is going where. And then we have high, which is going to be our data.length minus 1. So remember that throughout. Then we come down here and we have data, which is going to be our original part. Hold on now. If we go back up here again, we have data, low, middle 1, middle 2, and high. So low, maybe I should call this low as well so that you can see where it is. Low being 0 is going to be your left index. Right index is going to be middle 2. Middle 2 we know already. Middle 2 is middle 1 plus 1 over. So it's the middle of your array plus 1 element over. Then combined index is going to be 0 again. We're going to have our temporary array, which is the same length as our data array. So this is now our combined from our data. So we have our merge here, which is going to convert everything into our sub-array string by passing data left middle 1 being the halfway point. So our original array, left being the element at 0, and middle 1, data again, middle 2 being middle plus 1 element over, and then right. And right then, as we know, is high. And what's high again? High is passed here through sort array, which is going to be our data length minus 1. So that's our last element. Now, I think we can kind of see overall what's happening. So we have our left index then here is less than or equal to middle 1. Our left index 0 is less than or equal to middle 1, which is the middle point. And our right index, which is up here, which is 1 element over, is less than or equal to right, which we know is passed when it's called, is high. And what do we know high is? High is where it's called data dot length minus 1. So variable names, you can call them whatever you want. Sometimes it's easier to call them different names within different methods. Other times it's easier to say, let's say if I was to say instead of right, I could type in high here instead, to make it easier to kind of read as well. Maybe sometimes it's better to use different names so that you're not confused that it is an actual different method that you're calling. Other times it works out differently. So here we have our place the smaller of 2 current elements into result and move to the next space in the array, in arrays. So we have our data left index being left, which is 0, less than or equal to data right index is middle 2, which is going to be the middle point plus 1 over. And then we're going to assign the left index plus, or if you remember the incrementation now, this is part of it. So you're incrementing by 1 each time. Same with here, with the right index is now going to be assigned into here. The same goes then for left index is equal to middle 1. And then we also have a while right index less than or equal to right, and so on and so forth. I'll put the code up on GitHub. I hope you liked the video. Please like, share, and subscribe. And if you want another video for merge sort, because I know it can be a little bit tricky to follow, and it is the efficient way to sort anything. It works out more efficiently, but the code itself is a bit longer because there's more things to do. As we saw with linear search, linear sort was a bit funny because linear search was just like a whole line and you just figure it out as you go kind of thing, and it's really inefficient. Binary then is basically your true or false, so you split in 2 and then you figure each of those, blah blah blah. And then we also had insertion sort as well. So anyway, we're getting there. We're moving on to the next topic in the next video. Please like, share, and subscribe, and thank you for watching. Bye.